Hi everyone. I'm sorry I won't be here today, but hopefully this video will help you to get a good understanding of doing parametric equations with Pythagorean, that sounds funny, Pythagorean identities. And then your homework is a math Excel that goes along with it. So once you finish watching the video, you can go ahead and give the math Excel a try. All right, so the first thing we're going to be talking about here is understanding that you're going to have parametric equations that are going to be defined using trig. A lot of times it'll be sine and cosine together or tangent and secant together. And so in order to make this work, the best thing that you can do to figure out how to graph this thing is to solve your equations for sine and cosine so that you can substitute them into this particular identity, cosine squared plus sine squared equals 1. So here's the first example I want to show you. So you are going to start with these parametric equations that are x equals 4 cosine theta and y equals 4 sine theta. And so you're going to solve for sine and cosine. So you see how we divided by 4 each of them, and you have x over 4 equals cosine, y over 4 equals sine. That's still not quite good enough to make it look like this. So what you really need to do is square, I guess maybe I can give you an extra step here, is square both sides of your two new equations. So if I take this thing and I square the left, it's x squared. Let me write it so it looks the same as below. It's x over 4 squared equals cosine squared. And then this is y over 4 squared equals sine squared. So you've squared both sides, and then you're going to substitute x over 4 squared in for cosine squared, and this sine squared part, which is y squared over 4, goes in here. And then you may want to simplify it so then it looks like this, right? So again, kind of another step that I didn't show you here. So I could rewrite it. Oh, that's fun, sorry. X squared over 16 plus y squared over 16 equals 1. And then I multiplied the whole thing by 16 to get this as the equation of a circle with a radius of 4. It's true in both parametric form and in rectangular form that this is what's created, but the parametric form would give you a starting and an ending value. So we're going to go ahead and then graph this. So in our world, we would just do a table of values, right? So you've got t, although I guess this is in terms of theta, right? Doesn't matter, t, theta, whatever. And you've got x and y. Now we know this is a circle with a radius of 4, right? So if I were to just graph this out, it would be some circle, okay? But what we want to know is where does it start, what direction does it go, and where does it end? So even just by starting off with time or theta equal to 0, remember my first equation was 4 cosine theta for x. So I put 0 in for theta, and I end up with 4 for x. And then remember my y equation was 4 sine theta. So I put 0 in here, and I get 0 for y. So this tells me that my circle starts graphing over here at this point right there. Then maybe I just pick another value like pi over 2, okay? And I put pi over 2 into cosine. Cosine of pi over 2 is 0, so that's x is 0. Then I put pi over 2 into sine. Sine of pi over 2 is 1 times 4 is 4. So what that tells me is my next value is here. So my circle is graphing all the way around this way. And we'd want to make sure that this was creating the whole circle, so you could keep plotting points until you would see that this does graph the whole entire circle. Desmos does a pretty nice job of also showing you how to graph stuff. So I want to show you how to type it in and then show you it graphing itself. So notice here, I did it with a slider so you can see, so let me pause for a second. I called the slider A of t, that way we could see it graphing for each of the angles. So you can see it starting at 4, going in the counterclockwise direction, and once it hits 2 pi, it should be done. Actually, it's not even going to, well, you can see the time is 2 pi actually, so it does take the whole entire 2 pi to graph. This is just changing the value in front of the t to help you out. Now, if you don't want to do a slider and you just want to see the graph, sometimes what I'll do, so let's say I'm going to do 4 cosine t, 4 sine of t, so you can see that it automatically gives you the bounds from 0 to 1. So let's say I go from 0 to pi. Well, now you can see that I've got half of the circle. 0 to, let's even say 3 pi divided by 2. Now you've got 3/4 of the circle, and therefore if I go from 0 to 2 pi, you can see the whole circle. So that's kind of a nice way to fix that. I'm going to leave this open in case we need it, in case we need to come back to it. Okay, so now we've got a couple more, and we've changed both the values in front of the cosine and sine, as well as changing where the sine and the cosine are located. So on the second one over here, you can notice x has the sine. This is going to change how it graphs. But either way, the method is the same. So I am going to solve for cosine and solve for sine. Then square both sides. So this gives me x squared over 9 equals cosine squared. And y squared over 4 equals sine squared. And again, I'm going to use the sine squared plus cosine squared identity. And what you'll notice is we are no longer creating a circle this time, but we are instead creating an ellipse. So this, when we substitute, will be x squared over 9 plus y squared over 4 equals 1. Okay, if you remember how to graph an ellipse, we have the ellipse center is at 0, 0, and the major axis is under the x. The distance here would be the square root of 9 is 3. So here is my ellipse. It looks like this. Okay, but maybe you don't remember that. Maybe graphing an ellipse is just, it's not something either you remember how to do, or it's maybe just too time consuming to do anyways. So then you pull out your table of values for your parametric equations and substitute time from 0 to 2 pi. So I'll start at 0. So when I put 0 in for x, cosine of 0 is 1. 3 times 1 is 3. Sine of 0 is 0. So I start at the point 3, 0. So there it is. Now let's go to pi over 2. Once you do a few of these, you'll start to see the pattern that's developing. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. 1 times 2 is 2. So I get to this point now. And again, if you don't know what these values are, if this escapes you completely, just keep putting more values and put pi in. So I put pi in. Cosine of pi is -1. 3 times -1 is -3. And you end up with 0 again for the y value. So now you're plotting -3. You can see that 3 pi over 2 is going to end up here. So the graph is moving counterclockwise. All right, let's do this one over here. I want you to notice this time that the sign is with the x as opposed to with the y. This is actually going to change the way this graphs. So I divide by 3, I get x over 3 is sine of t. Square it, x squared over 9. And then, oh, I guess I need to do this extra part, right? So y, trying to jump ahead here. Come on. Y over 4 equals cosine. So when I square it, I get y squared over 16. And then that whole equation will equal 1. This is another ellipse. That's all we're really going to worry about. And the center's at 0, 0. We're going the square root of 9 to the right and left, and the square root of 16, which is 4, up and down. So this would be the one that has the major axis on the y-axis. Okay, but again, this doesn't really tell you where it starts and what direction this is going. So now again, you're going to want to do your table of values. I am running out of space. And you might not need to do a whole table of value. You might just need to do enough to help you figure out the starting point and the direction. So remember, this was x equals 3 sine of t and y equals 4 cosine of t. So when I'm substituting 0 in for t, now my sine is on the x and sine of 0 is 0. So my x value is 0. And when I put 0 in for cosine, I get 1. 4 times 1 is 4. So I'm actually starting at the point 0, 4. So I'm starting up here. Okay. Now I just need to know, well, am I going left or right next? Am I going clockwise or counterclockwise? So let's try pi over 2. So sine of pi over 2 is 1. 1 times 3 is positive 3. Cosine of pi over 2 is 0, so this point is then 3, 0. So my next point is at 3, 0. So that means we are actually moving in the clockwise direction. All right, on to the back here. So for this one, I think I'm actually going to have you try this on your own, and then I'm just going to tell you what the answers are. So I maybe like pause the video so that you can try them, and I'm just going to tell you what the answers are. But what you're trying to do is match A, B, C, D, E, or F with 2, 3, and 4. So which one is A, which one is B, and C, or whatever. Okay, so you're trying to figure out, hey, what happens if I change and make something negative versus positive, if I put the cosine first and the sine second, or vice versa. But just as a hint over here, this is an ellipse. That's x squared over 1 plus y squared over 9 equals 1. And the bounds are also different. Okay, so pause the video. So I'm now going to tell you what the answers are. So number 2 goes with A. So number 2 is A, and its time bounds would be from 0 to pi. Number 3 goes with C. And then number 4, let's see, number 4 goes with E. So it's A, C, E. Okay, so write those down and then maybe even copy them down. And then if you don't understand, ask me the next time I see you in class to go over this in particular. Okay, number 5, A and B now is kind of doing the same thing as what those matching did. So if you didn't understand the matching before, maybe you'll understand it now as I do this. So A says define a set of parametric equations and the bounds on T for the circle if the circle should only be graphed in the first and the fourth quadrants and should graph in the clockwise direction. So if this is a circle has a radius of 5, okay, so this is 5 here, 5 here, 5 here. We only want it to be in the first and the fourth, and we want it to go in that direction. So we want our starting point to be 0, 5, and then we want it to go to 5, 0 next. Okay, so the first thing I would tell you to do is to divide the whole equation by the 25. So it looks like this. Then you're going to rewrite it as x over 5 squared plus y over 5 squared equals 1. And maybe you don't even need to do this. As you get the hang of this and you understand the process, you'll probably be able to jump to the answer a lot faster. So I know that it's x equals 5 times either cosine or sine, and y equals either 5 times cosine or sine. And it depends on where we want it to start and what direction we want to go. We could even make it positive or negative if we wanted to. So I wanted to start up at the top. So I want my y to have a value of 5 and my x to have a value of 0. So that means when I substitute, if I want my bounds to, let's say, be 0 to pi, okay? When I substitute 0 in to t, in my x equation, it has to give me 0 for an answer. Well, I know that sine of 0 is 0, so this is a great equation for this because I put 0 in for t. Sine of 0 is 0 times 5, still 0. And I need my y to be a positive 5. So this would be a good example of putting cosine of t here. cosine of 0 is 1. 1 times 5 is 5. So I get this point. Now we just want to check, are we going in the clockwise direction? Am I going over to 5, 0 next? So put pi over 2 in for t. So when you put pi over 2 in, that's 1. 5 times 1 is 5. Put 0 in for t in the y equation, and I get 0 for y. So this set of equations where I do sine for the x and cosine for the y on bounds of 0 to pi will give you, starting up at the top, going in the clockwise direction. If I wanted it to go in the counter, let me say this, if I wanted it to go this way, okay, if I wanted it to go around this direction instead in the second and third, then I would have made my y be negative. Made my x be negative so that my next point would be negative 5, 0. So make x be negative if you want to go this way. All right, part B, same information. So it's the same circle, but now I want to only graph in the third quadrant and should graph in the counterclockwise direction. So I want my points to be here and here, and I want to graph in that direction. That's clockwise. Look at me, I can't even remember how the direction that my clock goes, right? Yes, that's clockwise. I want to go in the counterclockwise direction, so this way. So I want to start at negative 5, 0, and then next go down to 0, negative 5. So again, it's going to be something with a 5 for the x and a 5 for the y. They might be negative or positive depending on how we want to do this. And then try and get it to go in the counter clockwise direction. Sorry, I had to make sure I was reading that correctly, and my brain keeps thinking it's the wrong thing. All right, so if I make this x be cosine and y be sine, and I start at 0, cosine of 0 is 1. That would give me positive 5. So if I make this negative, then that will give me negative 5. Then I want my next point at pi over 2 to be down at 0, negative 5. So cosine of pi over 2 is 0. That works fine. But I need this to be down at the negative value, so I'm going to make that be a negative. So my final answer is negative 5 cosine t for x, negative 5 sine t for y, with just a little window from 0 to pi over 2. All right, last problem we're going to do is pretty quick and easy as well, I hope. It says a carousel has a diameter of 30 feet. So I'm going to draw a quick little sketch of this. So if my diameter is 30, that means my radius is 15. Okay, so here's my carousel. So going around like this. It says, write a set of parametric equations to represent the motion of the carousel given that the carousel moves in a counterclockwise direction and takes 60 seconds to make one rotation. So let's just say we're starting here at 15, 0, okay, and we're going this direction. That means, okay, so I'm even going to draw a quick little table of values. So at time 0, we're at 15, 0. If this is taking 60 seconds to make one rotation, over here at negative 15, 0 would be 30 seconds, which means at 15 seconds, we'd be up at 0, 15. Okay, so I've got a little bit of information to help me get started. The main thing that's going to change is going to change how I write what's inside my equation with the t. Okay, so if I were to just do x equals 30 cosine t and y equals 30 sine t, that would give me this circle, but it would graph from 0 to 2 pi. So this would be on 0 to 2 pi. Well, I have to change that. Okay, so I need to make it be from 0 to 60. Okay, so that just means you're changing that b value that goes inside with the t. So think about how you normally change the period of your graph. So the period is normally 2 pi. We want to change it to 60. So we're going to take 2 pi and divide by 60 to then use that as what we would call our b value, or the number that goes inside with the t. So this will become pi over 30t, and then y is equal to, and I just realized I wrote 30 and it should be 15, yeah? Sorry, let me finish this. It should be 15 because the radius is 15, not 30. I think I started writing 30s a whole bunch of times thinking about that 30 in my problem there. So these should all be 15 because, again, the radius is 15, the diameter was 30. Okay, it's even written on my paper correctly. I transpose things in my head all of the time. All right, hopefully that makes sense. Make sure you come to class with questions to ask if you are confused, or even if you're not, you just want to have some clarification. Hope you have a great day.